Hello and welcome to this lecture on overview of key XR concepts. At the end of today's lecture, you would have learned to explain how perception constructs reality. You would have understood the role of sensory systems in XR. You learned to distinguish immersion from presence. You learn to explain embodiment and agency, and you will be able to identify causes of sensory conflict and cyber sickness. Let us start with this video. So, this is known as Ritchie's plank experience. This is a VR app where there is a plank outside a tall multi-story building, and you can see as a user walks on this plank out of the building with the headset on, literally feels like he is slipping off the plank and falling down. Here are some other similar experiences where people are experiencing flying or maybe putting out a fire. Maybe traveling with a missile head and exploding mid-air, or maybe even experiencing hitting something in the process. So, even though the user may be aware that they have put on a headset and they are in the real world, despite that they get the feeling as if they are transported into these experiences. So, this is an example of how immersion occurs. To understand immersion, we really need to understand the human foundations of XR. So, my opening question to you is, well, why can people experience fear while standing on a virtual cliff even though they know they are physically safe? So, although they know that they are physically safe, they still experience fear. So, core idea from this example is that XR technologies work because they truly exploit the mechanisms through which humans perceive and interpret reality. Now, what do we mean by reality? Well, when we say reality, we often assume that we directly perceive the world. However, to experience reality, light enters the eyes, sound enters our ears, pressure stimulates our skin receptors, and eventually neural signals are processed by the brain. So, what we are experiencing in our day-to-day lives is not reality itself, but the brain's interpretation of the sensory information that is entering into our eyes, our ears, our skin, and so on and so forth. So, from all of this, the key design insight that we can get is that XR designers are not merely designing pixels, they are actually designing the perceptions. They are shaping the perceptions which we have and making them mimic the perceptions we have in our day-to-day lives. Here is what a third person perspective of a virtual reality system looks like. There is the organism who is connected to some VR hardware. The VR hardware is constantly tracking the organism, and equally it is stimulating the organism with some maybe display input to the eyes or some audio input to the ears. So, there is some kind of stimulation going back and forth. So, there is a tracking of the person by the VR hardware is stimulating the organism. At the same time, the organism is still embedded in the surrounding physical world. So, the organism and its interaction with the hardware, the interaction, the two-way interaction is equally important in VR. And the VR hardware is itself situated in the surrounding physical world as the organism. So, the organism is not only having an interaction with the VR hardware, he or she is still embedded in the surrounding physical world with which there is some interaction going on. Okay, so, for instance, you may be wearing a VR headset and experiencing this plank phenomena, and you may lose your balance and fall down and your knees may hit the ground. So, indeed the physical world does not go away, the physical world is still there while you are having your VR experience. Let us look at this a little bit more closely. We can understand this better by seeing human perception as an information processing system. Now, when we are in the real world, you can see what happens. We get natural stimulation from the world. So, our sense organs such as our eyes, our ears, our skin, etc., get stimulated from the world naturally, and that triggers neural pathways which then travel to the brain, and our brain processes all of this information and also exerts a configuration control on our sense organ, in the sense that it controls how our sense organs respond to the stimuli. So, let us say suddenly you wake up in the morning and there is a flash of light, maybe your brain will send a signal to close the eyes back again. So, there is a configuration control going on that the brain exerts on our sense organs, and that is based on the processing of the natural stimulation by the neural pathways. Now, when we replace the real world by a virtual world generator, this virtual world generator is then shown on a display, and that consists our new world. What we see on the display is part of this new world, and this display is then sent to the sense organ. Again, that gets processed through the neural pathways, and the brain exerts some configuration control based on how it interprets the signals that are coming from the display. Now, this perception of our brain is active, it is not passive. It continuously reacts to the signals it is getting through the neural pathways. The brain is continuously predicting and interpreting sensory input. Prior experience influences our perception. So, if you see the same virtual environment another time, you may find it to be artificial. So, the same virtual environment may feel realistic to one user and artificial to another. Maybe if somebody has had a prior experience of the virtual environment, he may find it to be artificial. We can understand this better by seeing our perception as being part of some hierarchy. For instance, visual processing occurs in different stages. We first detect light, and using the light we may detect the edges of an object, we may detect some motion in objects, we may recognize some shapes in objects, and we may recognize as a result some objects. And by recognizing the objects around us based on their shape, their motion and edges, we will then be able to understand the scene that is being presented to us. For instance, something like this. So, this is the scene that you may see when you are in the city center, for instance, with a number of shops and roads. So, in this scene you can see there are some buildings, there are some people, and there is this crosswalk, there are these roads. So, all of these are objects that the brain is sensing, and by detecting the edges and the motions in these objects and recognizing the shapes, it is able to tell more about the scene that it is presented. So, the implication of this hierarchy of perception is that XR systems must provide cues that align with these sorts of perceptual processes such as edge detection, motion detection, shape recognition and object recognition. So, the implication of this hierarchy of perception is that XR systems must provide cues that align with these perceptual processes. Various sensory systems are used in XR. These include vision, auditory system, touch, often taste as well, and our vestibular system and proprioception. Vision is usually the dominant source of information in XR system. So, XR systems such as the headset that I showed you in the welcome video has a display which actually captures our eyes and our vision. Equally, these headsets may have some speakers. So, the auditory sense is also being captured by such VR systems, and that usually gives us a spatial awareness and realism as well, similar to the real world where we experience audio all the time. Some VR systems may deal with touch. For instance, many of these modern headsets come with controllers, and these controllers will often give you haptic feedback such as vibrations. So, this kind of physical interaction and feedback is also part of typical VR systems. Some VR systems may even give you a sense of taste, and there the chemical composition is mimicked, so that you get a taste that you would get in the real world. In addition to all of that is our vestibular system, which works through our ears and gives us the sense of balance and motion perception, that is also usually taken care of by different XR systems. And you have the sense of proprioception, which gives us an awareness of where our body is positioned in the real world. So, all of these sensory systems are typically used in XR. The dominant sense is vision. Approximately 70 to 80% of the information humans use to understand their surroundings comes through vision. So, XR systems rely heavily on using vision to give you depth perception, motion perception, color perception, and also peripheral vision. So, a number of XR systems will use their displays to give you all of these perceptions, which you get in the real world as well: depth, motion, color, and peripheral vision. A key question to think about here is, well, why do most XR systems prioritize display quality over other modalities? So, based on what we have discussed here, can you perhaps think why most XR systems prioritize display quality over other modalities? Next, we come to auditory perception XR. We know that humans can localize sounds using timing differences of two sound events, intensity differences. Maybe something that is close by will have a higher intensity than something that is far off, and reverberation cues. So, some examples of these include hearing footsteps behind you or locating a virtual patient who is calling for help. So, this kind of spatial audio significantly enhances your immersion, and hence you will find that many XR systems include spatial audio. A key sense that is often forgotten is proprioception. It is the awareness of your body position and movement without any visual feedback. The awareness that you have with regard to where you are positioned in the world, that is known as proprioception. For example, you may close your eyes now and touch your nose. So, because you know where your nose is with respect to your body, you are able to close your eyes and touch your nose. You know where your hand is because of also proprioception. So, for instance, when I am speaking to you and underlining things, sometimes I may keep my pen away, and because I know where my hand is, I can take it close to this pen and lift it. So, this sense is typically forgotten, but it matters. It matters a lot in XR, because when physical and virtual body positions align, experiences feel natural. So, if you can get the virtual and the physical body positions to be the same, then you will give the user an experience that he is going to feel is natural. So, let us say you put on your headset when you are standing up, or you put on your headset when you are sitting down. So, you should get to see different views of the world depending on what kind of body position you have. Or let us say you rotate your body, then the display must also switch to show you a rotated view. When these positions do not align, then the presence you have in the virtual environment decreases. Users may become uncomfortable. Examples of where this matters is one where your hand is not being properly tracked by the VR system. If your hand is not being tracked and you make some gestures, you carry out some actions, then they may not reflect in the display that you see. Or let us say you have an avatar which does not have the same length as your arm, and then you may sense a mismatch between your body and the avatar which is representing you in the virtual world. So, indeed proprioception is a key concept, and I want you all to think about this carefully. The next key system that XR systems target is the vestibular system. The vestibular system is located in the inner ear. It provides information about the acceleration that you are experiencing, your orientation and your balance. It works closely with your vision, to determine where you are moving, your self motion. Eventually, the brain continuously combines information from multiple sensory systems such as vision, hearing, touch, proprioception, vestibular systems. So, combining the signals from all of these multiple sensory systems, the brain gives you an unified experience. This process is known as sensory fusion, the fusing of the information from the various senses that gives you information about the world you are in, whether it is the physical world or it is the computer generated world. Let us understand immersion a little bit better. We have talked about it in the first 3 lectures, but let us delve a little bit more into it. Now, immersion refers to the extent to which technology can deliver a convincing sensory experience. What it means is that immersion is all about how much you can get in terms of the sensory experience XR that mimics what you experience in the real world. Now, this is affected by a number of factors such as your field of view, the display quality, the spatial audio that you are hearing, the tracking fidelity of your XR system and the touch or haptic feedback that you are getting from your XR system. So, all of these affect the immersion that you get from your XR system. Indeed, immersion is a property of the system. As to what extent can you get a convincing sensory experience? As opposed to that, there is the concept of presence. Presence refers to a psychological sensation of being there. Okay. So, if you are putting on an XR display, are you actually in that world or are you still connected to the real world around you? So, that is the concept of presence. Unlike immersion, presence is the experience that the user is getting. A highly immersive system may not always produce strong presence. So, immersion and presence do not always go hand in hand. So, sometimes they will go hand in hand, but other times they will not. So, let us distinguish immersion and presence. We can say that immersion is a technology property, it is a property of the system that is immersing you, whereas presence is the human response, whether it is your choice whether you want to be present in that world or not. Immersion is objective, we can tell whether a particular system is immersive or not, we have metrics to measure, whereas presence is often subjective. It depends on how a person himself feels whether he is in that particular environment or not. So, immersion is measurable, as I said, there can be metrics that can be measured, whereas presence is psychological. Immersion needs to be designed, okay. Immersion needs to be created by the creator. So, if you are a game designer, you may design that immersion into your game, whereas presence is dependent on your experience. If you experience presence or not, that is the user's own feeling. So, for instance, watching a 3D movie may be quite immersive, but not necessarily create presence. You may not feel that you are part of that movie. However, if you are exploring a world where you are able to walk through in it and make some user actions, that may give you some higher sense of presence in that world. So, just watching the movie, it may immerse you in the movie, you may enjoy it, but you may not feel that you are present inside that movie. Okay. Hopefully, that makes sense. Let us understand the different types of presence now. Presence can be of 3 types: physical presence, social presence and self presence. Physical presence is a feeling of being located within a space, whether you are part of that space that you are experiencing or not. Social presence is the feeling of being connected with others. Are you connected to the people or the objects or the animals, etc., which are there in that environment? Then there is self presence, which is feeling ownership of a virtual body. Let us say there is an avatar that is representing you, are you feeling that you are actually owning that body or not? So, there are 3 kinds of presence. You need to think about this when you are designing your XR system or your XR environment. When you are designing a 3D world, you may then think, well, have I designed physical presence into it? Have I designed social presence into it? Have I designed self presence into it? Next, we come to a concept of embodiment. So, often in virtual reality systems, you will use what are known as avatars, and we have seen in many 3D games etc., and in 3D environments that users will often feel attached to the avatars. Initially, they create an avatar which feels a little distant, but once that avatar starts taking actions on behalf of you, you suddenly feel connected and attached to that avatar. And that feeling of being attached to an avatar is what is known as embodiment. That is, your body is being captured by the avatar, and that avatar is embodying you, or it is actually representing you. So, embodiment consists of three things. That one is self location, which is locating yourself in that environment. Agency, that means the ability for you to do something as part of that being part of that avatar, and owning that body. So, if you can give all three of them, then you would have embodied the user very well. Self location, agency and body ownership. Examples of embodiment are virtual hands. So, very often when you put on a VR display, you will see that there are some virtual hands that appear within the display. So, they are actually representing your hands. Another example of embodiment is that of virtual patients, where there is a patient which represents you in the virtual world. Robotic telepresence systems also give you a sense of embodiment. A robot may embody you and be located in some other environment, and it might be carrying a camera which is showing the world around that robot. And so, you are essentially embodied by that robot. Here are some examples of robotic avatars. So, you can see here this is a robot which is located in a certain location, and the user who is remote from the robot, and this robot is known as a Dora robot, is from the University of Pennsylvania. The user has put on a headset, and through the headset he is able to see exactly what the robot is seeing. So, a Dora robot from the University of Pennsylvania mimics the user's head motions, allowing him to look around in a remote world while maintaining a stereo view. So, this robot can look around, and equally this man will also be looking around. The motions which will be present in the robot are mimicked here. So, you can actually see what the robot is seeing, and the robot will see whatever you want to see. Let us say you rotate your head to the right, the robot's arm which is carrying the camera will also rotate to the right. So, you can see to the right, and the robot is essentially sort of your representative in this environment. Another example is that of the Plexi drone here shown on the right. It is a flying robot that is designed for streaming panoramic video. So, whatever images are being captured by the drone may give you a sense of flying. So, as if you are flying and capturing those images. So, these sorts of robotic avatars are becoming quite popular in XR these days. Yet another example is that of virtual societies. So, here is a particular virtual society game, where there are various people who are not there in person, but they may come to hang out in their avatars around a fireplace, for instance. So, avatars are connected to each avatar in this game is actually connected to some real person, and they have come around to have a hangout. So, people interact in a fantasy world through these avatars, and these groups of people could spend time together in these spaces for a wide number of reasons. Maybe to conduct a meeting, maybe to just discuss the latest football matches. So, for a variety of reasons they may come and enter this virtual space, and their real bodies are not present, but because you can see these avatars sitting on sofas around a teapot, they are actually able to feel as if they are part of this environment. So, these sorts of virtual societies are now becoming commonplace using various virtual reality apps. The next key concept that I want to discuss is agency. It is a feeling that one's actions produce some effects in the environment. So, it is not just sufficient to have your body being represented in the virtual world, but you should be able to do things in that virtual world. If you are able to do things in the virtual world, then you will feel that you have an agency in that world. So, it is a feeling that your actions produce some effects in the environment you are in. For instance, you may be able to open a virtual door, or pick up an object, or manipulate a surgical tool. So, that gives you a sense of agency. If you are able to provide this kind of agency in your virtual reality or augmented reality app, it increases your engagement in the app and it increases the realism as well. Let us look at a particular psychology experiment that will actually help us understand how our senses get easily fooled. So, this is known as the rubber hand illusion. We will now watch this video. So, here is a user and one of the user's hands is on the table and the other is a rubber hand. And you can see that the designer of this experiment is stroking both hands. One is a rubber hand and one is a real hand. So, right hand of the person is on the table, the left hand is not on the table, but there is a rubber hand and there is a cloth that is covering the rubber hand and going over the person's body. And even though the rubber hand is being stroked, you can see that the person is experiencing as if his own hand is being stroked. And as he strikes the rubber hand with a hammer, the person gets a jerk as if his own hand was struck. So, a fake hand was being stroked synchronously with the hidden real hand. The result was that people slowly started feeling ownership of the fake hand and started thinking that, well, that hand belongs to them. And this experiment really shows that the body ownership, the feeling of ownership of a body can be manipulated and our senses can be fooled into thinking that the avatar or the representative that they have actually belongs to them. So, this experiment has been repeated with several people and you can see in each case the result was the same. So, these sorts of virtual avatars may feel real because users can identify strongly with avatars when the movements match, when visual feedback is consistent and the interactions feel natural. Now, this is useful in various fields such as medical training, in the field of clinical or virtual patients which are represented in apps and in social XR. So, an example is that of virtual patients. So, let us say I create a virtual patients app and it is loaded on a VR headset and a trainee doctor puts it on. If he is able to feel that the avatars inside are real, then he is going to experience as if a real patient has come in, has some real symptoms and is able to diagnose and actually treat that patient, maybe monitor that patient, assess him and then treat him. Okay. So, that feeling of an avatar being real is crucial to the success of such apps for medical training and in social extended reality. Let us look at closely how VR is used in healthcare. Very often VR will be used for the purpose of distributed medicine, where doctors can train people to perform routine medical procedures in remote communities around the world. So, here is an example of how that can occur. There is a robo patient, robo doctor system that has been set up and the human doctor has access to a projected face, whereas a robo doctor is actually working on the real patient and the experiences that the robo doctor is getting through a tactile sensor array on the real patient are then being transferred into the feelings that are being projected on the morphed face. So, that the human doctor can sense what his actions are having an impact on the real patient. So, by guiding through telepresence as shown here, so this is a method in which there is telepresence using this robot and some electronics modules which are then being connected through the internet. There is a 4 sensor platform here which is giving the doctor the exact experience that the robot is sensing from the patient. So, in clinical training for programmable robo patients, this is an excellent application. The doctors may be able to immerse in 3D organ models which are generated from medical scan data, which helps them plan and prepare for various medical procedures, and also to explain medical procedures to patients or families who can then take informed decisions. VR is also used in healthcare to overcome phobias and stress disorders using repeated exposure. It helps improve and maintain cognitive skills despite aging. It can help improve motor skills to overcome balance, muscular or nervous system disorders. You can also use VR to improve longevity using remote travel opportunities and fun physical therapy, which actually make you joyful and buoyant, and it can help you overcome loneliness by joining in remote activities. A key issue to think about is that of sensory conflict, which occurs when sensory systems provide contradictory information. For instance, there might be visual movement that you might find without any physical movement occurring from you. So, if there is visual movement in your display when you have not made any physical movement, that can lead to a conflict between your senses. Or if there is delayed tracking, you make an action, but it reflects in the display much later. So, that can lead to sensory conflict. Equally, if the audio clues are delayed or inconsistent, that can also lead to sensory conflict. Another key concept is that of vection. It is the illusion of self motion. It is a feeling that you are moving while you are sitting still in VR. Again, this is another key challenge area that needs to be addressed. Here is an experiment that was conducted in the 19th century, where the users were kept still, but the room around them was made to revolve. So, that gave them the illusion that they were in a swing. So, users were experiencing motion because visual information were dominating their vestibular cues, which was telling them that they are still, but because of the movement of the room around them, they felt that they were also circling around. Now, all of this can lead to cyber sickness, which can give you symptoms of dizziness, headaches, nausea and fatigue. And the primary causes of such sickness is typically the latency that you are experiencing in the VR system, the delay, the frame drops that you may be experiencing, due to which the sense of motion may be lost, or a sensory mismatch, as we discussed in the previous slides. Over time, users tend to adapt to various sensory experiences, and experienced users can often tolerate conditions that new users cannot. So, designers must avoid designing only for themselves. They must think about new users who may experience it first time. As a designer, you might be testing the system over and over again. So, you may be used to it and you may not feel the sense, you may adapt to the system and may not feel the same sickness that new users may experience. Another key concept to understand is that of psychophysics, which is the scientific study of relationships between physical stimuli and human perception. So, how does physical stimuli lead to a certain sense of perception is crucial to understanding XR systems and evolving them as our journey into XR continues over the following years. So, typical questions to think about are, well, how much latency is typically noticeable in XR systems? How much is the tolerance range in terms of delays? How bright should my display be to not make the user uncomfortable, and how precise must my tracking be so that the user feels a sense of presence in the environment. Good concept in this regard is that of JND, or just noticeable difference. It is the smallest detectable change in stimulus. How much should the stimulus change so that I can detect it? For instance, how much should the brightness change so that I can sense that the brightness has changed in the display? The applications of JND extend to designing displays, giving haptic feedback to the users, and designing audio as well. Now, consider the JND for a stimulus with varying magnitudes such as brightness. The key question here is, well, how does the JND vary as the magnitude varies? This relationship is captured by what is known as the Weber's law, given by delta m by m is equal to c. Here delta m is your just noticeable difference, m is the magnitude of the stimulus, and c is the constant. So, at the least value of delta m, when I can sense that there has been change in the environment, that gives me my c. Okay. To summarize this lecture, XR is fundamentally about human perception. Presence emerges through our senses working together, or sensory coherence. Embodiment and agency are two crucial concepts to consider when it comes to immersive experiences, and sensory conflicts reduce our comfort and realism. So, we must try to reduce sensory conflicts when designing our 3D worlds. Some reflection for you. Please think about, well, why do some VR experiences feel realistic while others do not? You may analyze using presence, embodiment and sensory fusion. What I recommend is that you take up one particular VR experience and then think about what presence it gives you, what embodiment it gives you, and whether the sensory information is getting fused and processed well by your brain. Okay, looking ahead, we will next cover the fundamentals of AR, VR, XR systems in the next lecture. I thank you for your attention and look forward to seeing you in the next lecture.